Sorry about this. Yes, press the wrong button. Right, okay. So we had 2 periods for this campaign, just to make the point. I shall have to refer to these in the results that we saw. We basically intended to go in November and December to look at this pre-monsoon, looking at land-based convection, where you have these very deep storms. The thing in the background is actually one of these Hector storms. They reach up well into the TTL. In fact, they penetrate the tropopause, get up to 20 kilometers at times. And then over the land near Darwin, you get larger scale structures, small lines, which are basically agglomerations of these huge thunderstorms. And then in January, we were intending to look at the monsoon. Well, in fact, the monsoon turned up on time, which was very good. We had a very active monsoon, and then something that I didn't know happened. So I had to go to Australia to find out that there's such a thing as a dry monsoon. Dry monsoon was brilliant. It didn't rain, it wasn't humid, and the temperature was about 24 degrees. And it lasted for about 2 days, so it was like being on holiday because you couldn't do any work, there was nothing to do. And then it all started up again. It started to get very humid. It's pretty hot and humid in Darwin. It's not a place that you'd want to go walking very far. And then we were back to these monsoon break conditions. So basically we had a chance to sample all of the kind of weather they have there during the wet season. Okay, so let me try and press the correct button, that one there. Now this is our experimental method. So as I said, now here's the planes that we have. So these are beautiful planes too, Richard. Well, I thought they were anyway. I was sick of them by the end of the campaign, but anyway. So basically, this white splodge is supposed to be a cartoon of a thunderstorm. The idea being that we used, this is an NERC aircraft. This is the Dornier, based in Oxford. It's a remote sensing aircraft, but it was instrumented by our consortium to measure in situ things, aerosols and chemical constituents. This was measuring what was going in at the bottom of the storm. And it was in fact the only aircraft during this campaign, this whole international campaign, that actually did this job. The aerosol measurements from this have been extremely important for interpreting the rest of the campaign's data. So we were measuring all different kinds, both aerosol number density, the aerosol composition using a mass spectrometer, different types of aerosol, small and coarse aerosol, and then the group at York with Jackie Hamilton were measuring ozone, carbon monoxide, and lots of hydrocarbons from this aircraft. So we had a good characterization of the inflow to the convection, and the idea was that we use this aircraft to measure what was coming out the top. So what comes out at the bottom, what comes out at the top, all rather simple, simplistic I should say. This is a more interesting aircraft than that one. This is a German plane, and so is this one. Although in fact it's run by Airborne Research Australia, that's what the ARA stands for. This is a spy plane, built by the West Germans to spy on the East Germans. Only by the time the thing was flying, they could walk into East Germany, so they didn't need a plane. So there was a fleet of about half a dozen of these built by Grobe. This is the only twin-seater version of it, these Egret aircraft. And, well, they were a bit surplus to requirements, so they've kind of popped up in research institutes around the world. There's one of them flying in America with the ARM people. And ARA, one of them went all the way to Australia. Now, the great thing about the Egret, really, and if you work with aeroplanes and you find that it's an extremely frustrating thing. Trying to put an instrument on an aircraft usually involves more paperwork than you can shake a stick at. But not with the Egret. You hand over your instrument to the engineer, and he kind of nails it on the plane. It's an incredibly flexible tool, and indeed unreliable. But I won't go into the unreliability of it. But whereas this one, I think, is a better compromise. It too is reasonably flexible, but it's also reliable. Anyway, the Egret can get to about 15 kilometers. And it was clearly able to sample the main outflow level. In order not to complicate this slide too much, I'm not going to show all the other aircraft. There were 7 aircraft in all. There were 2 from Europe, the Falcon and the Geophysica. The Geophysica measuring here, and the Falcon with some LiDARs, basically again profiling in this region. And then the Americans brought a Proteus, which flies about the same height as this one, although it's supposed to fly much higher, but laden with equipment it doesn't go that high. And again, a composite aircraft just like this one. And they brought a Twin Otter, like you were showing, with some, again, with LiDARs on. And they also brought some another low-level aircraft with them. So this was an exciting time when all of this fleet got into the air. Not that they were all there at the same time. So, on to some measurements. And in fact, this slide, I was looking at this on the train and thinking, oh dear me, why did I put such an awful slide on? So they're not anywhere near as pretty as the ones you saw from Richard. But anyway, this slide basically summarises the conditions that we met during the campaign. And I've done this by showing you carbon monoxide concentrations measured by the low-level aircraft. So this is the Dornier. So this is measurements up to about 3 or 4 kilometres, not just the boundary layer, it's a little bit above there too. And all the data from the campaign are summarised on here. So each of these little blobs is a median value for each flight, and then you've got the upper and lower quartile like this, these little crosses. For reasons I won't go into, this is better than means, because there was a very long tail to some of these distributions when you hit a bit of pollution. Now what you do, what we found was we start the campaign in November. These black symbols are for the November period, and these red ones are for January. So this is the day of the corresponding campaign, in November or January. And we started off with a lot of pollution. We started off, in fact, with a lot of biomass burning. It turns out that Northern Territories of Australia is populated mainly by the Aboriginal people, and the Aboriginal people like burning things. In fact, Australia is the way it is, probably because of the Aboriginal people assiduously burning everything they can find. And so every year, about a third of the top end of Australia is set on fire. And this generates huge clouds of carbon monoxide and aerosol and other pollutants, the hydrocarbons that are associated with biomass burning. So we've got strong biomass burning, and here's this is 110, this median here is 110 parts per billion. This is flying out mostly over the ocean, and that tells you, that's quite high by Southern Hemisphere standards, as you can see. Then as we went through the campaign, you'll see in a minute, well, there's a difference between these two. The main reason there's a difference between these two is that egret broke and we had to wait for about 10 days to get it fixed. But in the meantime, it got a lot wetter. There were fewer fires, and so the levels of this thing had fallen. So we have, in these two periods, pre-monsoon conditions. Large continental convection, nothing over the sea, easterly winds. When we came back after Christmas, we saw far lower values of carbon monoxide. In fact, getting down, in this period here, this is down to about 40 parts per billion. This is the lower quartile here, about 45. And that's extremely clean air, cleaner than you would expect to find in the tropics, in fact. And the reason for that is because we had a long fetch of air from southern mid-latitudes during this inactive monsoon period. I'm not going to go on too much about that. But anyway, here's our active monsoon. You can see a decrease in carbon monoxide as the northwesterlies of the active monsoon